Bismillahirrahmanirrahim. Assalamu alaikum students. I want to welcome you all to this video, which is actually, I actually heard a guy, student saying that he forgets DBMS. So I'm making sure that you do not forget anything. That's why this video. I mean, if down the road, 1 month later, the concepts will fade or you forget something, you can open up the video and your concepts will be refreshed again. So this will be a quick recapitulation of what we had done actually. So this is the concept refresher. And here we go with a video on a relational model. Now, all the time the students wonder about the theory. But you should keep one thing in mind. The relational model is based on theory, no doubts. But keep one thing in mind, that nothing is so practical as a good theory. If you do not have a good theory or a theoretical background, a good concept, so practical is nothing for you. Keep that in mind. So a good theory is what you should be getting, and then you can go into the practicals. Got it? So let's get quickly into the concept of relational model. Now, where from the relational data model came from? It was the CORD. It was definitely the CORD. Okay, because the previous models like network, hierarchical, file-based, they were all having problems. So we switched on to relational data model, and it was based on the independence. And it says we should separate physical implementation from the logical implementation. Okay, you can understand the logical, conceptual, and physical three-tier architecture of DBMS. It was based on the CORD because here we are trying to describe data minimally and that too mathematically. Okay. And basically we have two things here. One is the relational algebra and one is relational calculus. So two things, relational algebra and relational calculus, because we have now the power of mathematics, so we can apply algebra and calculus on our database. Well, when the relational database came in, CORD's theories, but it took time. As you could see, in the 1970s was the CORD's original work, but it took a lot of time. If you see the earliest relational database research around approximately 76, and first Oracle 2.0 comes in 1979. So why the gap? Because we had the math formulas. Nobody was ready to write math formulas. And everybody was thinking, why we turn our data into the tables? Because we had relational, we had the networking models, etc. They were not dealing with the tables. So the question was, everybody was thinking, should we have the tables or not? So everybody thinking that maybe the tables, etc. It's a mathematical things. Will that work in the database environment or not? So this was the thinking going on. So what you think as well, huh? Relational data model is actually we directly didn't make the model. The first thing was actually the conceptual design. That is in fact our ER diagram, as you could see here. So who is taking what? I mean, which student is taking which course, and what grade do they expect? So what's the grade there? And also here we are seeing what professor is teaching which course. So this is to be mapped now into the tables, because we are discussing the relational schemas. Now if you talk about the relational schemas, so we had there the three things. One is student, one was the text. It was a relationship there, as you if you remember. And the course, if you didn't remember, just recap the video, just rewind, sorry, a video a bit. And a course, and a professor, and a teacher. And the teachers, as you could see, takes and teaches was the relationship in the ER diagram. So we have changed that into the relation, and student, course, and professor were the entities. So we have also mapped that into the relations or tables, okay, with their attributes. We'll see SID and name, SID. This is the grade and course IDs, and course itself has the primary key course ID, subject and semester. And professor has got the professor ID and name, and like that, teaches professor ID and course ID as well. So our focus is totally on the relational schema, which is the set of tables. So relational schema is set of tables, okay? We can also use some other kind of schema like XML, objects, if you got an object-oriented database, etc. We'll a lot of times use XML, which you will read in your future classes. Let's now have some terminology going on. As you could see, columns of a relation are called attributes. So if we have a table and its columns, what we put in the columns, it will be the attributes, is it? Or fields, okay, like name, roll number, SID, CID, whatever. And the number of these columns, how many columns do you have? You know, number of columns will be called the arity or the degree. What we have said, it is degree or the arity, is it? Good. And the rows of a relation are actually called the tuples, okay? And how many rows you have is its cardinality, is it or not? So if you have a table and you will see how many rows you got. If you have, for example, here 1, 2, 3 rows and the cardinality is 3. And there is a domain concept that, for example, the subject has a domain of string. That means what values it's going to take. So theoretically, what is a relation? A set of tuples. And remember one thing, no tuple can occur more than once. There is no redundant tuples in it. We cannot have redundant tuples, is it? You know, sometimes real systems allow duplicates for efficiency other reasons. This time around, we're going to ignore this because real system will tell more about that later on. So basically, when we say a relational model, we are talking about the model. It should have 3 things we should be discussing: data structures, first thing, integrity, and operators. Data structure we are already done. We say the data structure here will be a table, a relation, and its domain should be that it should take the values of the domain, etc. The second thing should be the integrity rules, and then the operators or operations. What operations we're going to do on these tables or relations. Now when we talk of constraints, in case of file-based approach, as you could see here, we try to put up the semantics of the constraints onto the application side. Application programmer have to put up the semantics, not the data side, okay? But in case of a database approach, what we are doing is we are disjuncting the application program from the semantics, and we're putting the semantics into the data itself. So constraints are to be built into the database. And now, what are the types of constraints? Okay, we have actually 3 types of constraint. One is the domain constraint, one is the primary key constraint, and one is the integrity constraint. Okay, the domain constraint simply tells us that the value should be taken from the domain. Primary key constraint tells us that there should be a primary key honi chahiye. And integrity constraint actually has 2 things in it. One is the entity integrity constraint, EC I will say, entity integrity constraint, and second thing is the referential integrity constraint. Okay, so what is the entity integrity constraint saying? Entity integrity constraint says that the primary key should not be null. Okay, and the referential integrity constraint says that if you have a foreign key, it should be pointing to the existing or corresponding primary key, because referential integrity is based on the primary key and the foreign key. So it tells us that it should point to the corresponding the primary key. As you could see here in this example, in this slide, we say entity integrity and referential integrity. Entity integrity says that no component of the primary key of a relation can be null. Okay. And next thing is that referential integrity says that a database must not contain any unmatched foreign key value. And for every foreign key, there is a corresponding primary key. What I'm going to say is, if you go to one table here, this is, for example, a foreign key, and with another table, this is its primary key. So if I'm saying the primary key is here, it should point to the corresponding primary key. That if something is here, then it should point to the valid corresponding primary key. If we are saying there's nothing, for example, there is no such primary key, then here it should be null. So you're understanding it. Good. So the next thing, as the data structure and integrity constraints, etc. are done, we now move on to the operations. And I'm going to say operations is actually the relational algebra. Okay. So what is a relational algebra? Actually, in relational algebra, we have operands and operators. So in relational algebra, operands are what? किसके ऊपर आप operations करोगे? Actually relations. Okay, it will be tables on which you will do your operations. And an expression evaluates to a relation. यानी कि आपका एक table है, you will be doing some operation on that, and what will yield? What will be the answer? The table itself. So input is the relation and output is also the relation. Okay. And relational algebra operators, either they could be set based, like unions, intersections, etc., or either they will be some operators, they will be removing some tuples, they will be removing some, like some attributes or columns. Okay. Or there could be some guys who will be joining the two tables, and these two actually are unary. They work on they work on not this one, sorry. Set operations are binary, but these guys are unary operators. They will like selection and projection, they will work on a single table, and these guys join, they work on the two tables. So that you mean what I mean to say here is, if you want to do selection and projection for two tables combined together, then we have to use a join or a Cartesian product. Now this will give us that thing, that what I said at the beginning, that that in database we have the complex data retrieval. And there is one more thing called a rename operator, which can rename the name of a relation or its attributes. If the student relation, I can change its name to the ST, for example, or inside there is a student name, I can change it to the name. I mean, say attribute is the name, I put it there NAME, so I can change the name to the STNAME, student name, like that. So if I want to change sometimes for some reasons, which we will see later on, that we have a rename operator shown by the row. Okay. So here we are, that we have the set based operations and the relation based operations. With the set based operations, we have union, intersection, set difference, and Cartesian product. I would say relational operations, we have select, project, join, and division. Okay, but before we do the basic set operations, and they need to be what's called as union compatible. When we say union compatible relations, then what does that mean? Union compatible relations, that two relations R1 and R2, R1 here we have written R and S, the two relations. R is with the attribute A1, A2, AN, and S is with the attribute B1, B2, Bn. They are said to be union compatible if they have same degree and same domain. So they should be having domain same as well as degree same. What is degree? Number of what? What is degree? Yes, number of columns. Is it? Good. So they should have same number of columns, but only columns will not work. For example, we have two guys, they have two columns. For example, they have three columns here. Another table is having also the three columns, but this is saying name, this is saying a roll number, this is saying class, and now this is saying, for example, here another table which is saying part number, like part number, like cost, and like tax. Now these three guys, if you could see, these two tables are having the same degree, that is 3 number of columns, but they are not domain compatible, so you cannot do the union or intersection on them. Okay, so then we want to do the union. So when we say union, it just combines the two tables, but remove the redundant ones. If they are something someone coming twice, you should not be taking that. Now here we have 1 2 3 4 and 5 6 7 8, and how many are coming in the result? 1 2 3 4 5. That means somebody is repeating, like A1 B1 is repeating here, as you could see. So A1 B1 will take it only once, which was taken here, not the twice, and so on. And in the intersection, very simple, that we will take the common ones. So what is the common here? So we have common ones are there, like A1 B1 is common, it's also here, so we'll take up in the relation A1 B1 here. Okay, then we will see A2 B2, the A2 B2 is here, it's also here, so we take up that A2 B2, and A7 B7 is not here, so we will not take it. A4 B4 is there, so we will take A4 B4 as well. So what are the common ones? Take them together. Next thing here is the set difference. What is set difference? Set difference is what is in R1 and not in R2, or simply in shortcut, R1 and R2 का intersection करे and remove that, because here what is common? A1 and B1 is common, so don't take it from the R1. Similarly, there is A2 B2 is common, as you could see, we will not take that as well. A4 B4 is also common, so I will not take that as well. So from these, what remains there? A3 B3. So my answer will be A3 B3. But if you do a reverse of that, R2 minus R1, what is left from the intersection? That's A7 B7. Then answer will be A7 B7. You got it? So answer here will be A7 B7, as you could see here. Now next candidate is the Cartesian product. Okay, when say Cartesian product, simply do what? If whatever is in R1, for example, there is C1 and C2, product every C1 with every tuple of R2. That is first C1 with A1 B1, then A2 B2, then A3 B3, then A4 B4, and so on. Similarly C2 with these guys. So if it has a cardinality of 2, it has a cardinality of 4, and we will get here the cardinality of 2 cross 4, that is 8. Okay, so now is the time for the relation based operations. So relational operations. So what are relational operations? First thing is the select. Select will do what? We have a symbol here, sigma. It will have a sigma, then we need to have a selection condition and the table name. Okay, and selection condition can be anything you want. For example, we say select age less than equal to 30 from the table person, right? Okay, let's see here another example of the selection. We got an example here that is saying that cells, table name is the sales. Okay, we've got three things here: bars, beer. Oh, it's in beer. Don't say example, I mean shit. Anyways, don't worry, I will cancel it out. I will say it is Zamzam. Okay, it is Zamzam, Abi Zamzam. For this is a bar. I will say bar like that. I will say shop. Okay, it's a shop who is selling Abi Zamzam, and with having some price, very little price, at the rate of rupees 2.50 per gallon. Okay, enjoy, whatever. Now we want to do a selection. I would say select bar is equal to, I should say shop. I should say shop is equal to Joe's. I want a shop of Joe's. Why shop of Joe's? From the sales. So I want to select those tuples, because selection, when I say select, it means give me the tuples. so the degree remains intact. It will not do anything with the degree. So select, say Joe's here. I'm saying shop is equal to Joe's. So Joe's shop. So these two tuples will come up in the resultant table. So for a relation-based operation, input is this table is the input, okay, and the output is again the table. Fine. But as you could see, cardinality is getting reduced because we get only those tuples which were in a condition. Because I'm telling him, give me those. Give me the tuples or record of the guy of where the shop name is Joe's, where the shop is equal to Joe's from the table sales. So simply sigma will mean selection condition, then the condition here. This is the operator sigma, then the condition here, and the table name on this side. Got it? Now, when we say the projection, for example, projection is shown with the pi. Then we need some attribute list, like attribute list will be here, like one attribute, then comma second attribute, then comma third attribute. So I want 3 attributes only from the table. Table name will be here. Fine. Again, we got the same example, like this is a shop and this is the Zamzam and this is the price, for example. Now we say project. I want the Zamzam and price. I want the Zamzam and price. Now I'm not interested in the tuples. I'm interested in the attributes. I want to get only attributes, Zamzam and price. So only these two guys I want, not this thing. There could be many attributes also, but I want few attributes, for example. Now I'm saying give me project, Zamzam and price. So project, Zamzam and price only. So for example, I will say here like this, if you want to see, do it like this, I say project, Zamzam attribute, comma, what will be here? Attribute list, Zamzam and the price from the table. What is the table name? Sales. I should say sales. Got it? So price and Zamzam, give me only these two attributes. And it will give us attributes of all, but if you could see here, we have here 1, 2, 3, 4, but it's getting only 3. So why so? Because the bud with 2.50, it is redundant. So it will be written only once here. Now you can question why the Miller is coming 2 times. Because Miller is not totally redundant. Because with this Miller it's 2.75, with this Miller it's 3.0, so they are different, so they will be taken out. Now that is why we said in the lecture, in the class, that in the projection the degree gets reduced as well as cardinality gets reduced. As you can see, cardinality here is only 3 when it was here 4, so it is getting reduced. Degree was here 3 and it is here 2, so degree is also getting reduced. So if you remember this dialogue here, that Mamu wala dialogue, okay, and I'm drawing here, you could see this selection में cardinality कम होती है और projection में दोनों बोले तो cardinality भी और degree को arity भी बोलते हैं ना, भी कम होती है. You got that? Now is the time for the join. Now join, actually जब हम दो tables को join करना चाहते हैं, so we need to do join if we want to do selections and projections of 2 tables, and join is of many. Now first type of join is the Cartesian join or the canonical join. Okay, ये join तब होता है कि जब आपके पास कोई condition नहीं है join का. So what will the DBMS does? DBMS will do what? It will combine all the combinations together. जो भी आपके tables है, table 1 यहाँ पे है, table दूसरा ये है, इसकी जितनी भी combinations बनेंगी इनके साथ, जैसे हमने Cartesian product किया था, इसी तरीके से इनको दोनों को ज्वाइन कर लेगा. सो एक बड़ा सा टेबल बनेगा जिसमें तमाम वो ऑप्शंस आएंगी, दिस क्रॉस दिस. इफ इट इज m, इसकी कार्डिनलिटी m है, इसकी कार्डिनलिटी n है, सो इट विल बी m क्रॉस n टेबल. सो ह्यूज थिंग. So the next join condition actually is a theta join, which says that when you have some condition, so when you are having some condition, you can use a theta join. And theta here actually means the condition. The theta जो आपके यहाँ पे है, that means itself that there is some condition. Okay, like we're saying the car price is greater than equal to boat price. So we want to join the two, car and boat. This is the join symbol. Okay, then car price, under the join symbol I am writing the condition here, and the condition is that car price should be greater than equal to boat price. So I am joining the car and a boat, but on the base of car price. And you could see boat price and car price, they are having commonality, so I can join them on the base of this price. So when I'm saying car price should be greater than equal to boat price, that means I'm taking only those joins. If you see the previous one, the canonical join, okay, the canonical join, especially for Shaista, if you watch it out carefully, that if you see canonical join, in canonical join, what will the DBMS does? It will combine everybody, like car A 2000 with this guy, car A 2000 with this guy, car A 2000 with this guy, okay, with everything. Then car B with this, then car C with this. This will be a huge table. But here we are having some join conditions, so we can join them on the basis of car price and boat price. So what we are doing here is we are seeing that car price should be greater than boat price. So if your car price here is 20,000, what is boat price here? 10,000. So it will be joined because car price is greater than boat price. So we are joining it here. Now will car A will join with this? No, because car price 20,000, यहाँ 40,000 कम पड़ रहा है, नहीं करेंगे. 20,000 here 60,000, so we will not join. Now car B की बारी आती है, इससे join करेंगे? Yes, because 30,000 10,000 greater है, तो car B will be joined with the boat one. Similarly, we have the car C. Will car C be? I think it's coming. The video is getting out of range. I will minimize a little bit. Okay, now it's coming. What I am saying here is that wait a sec. Okay, now car B 30,000 will be combined with this as it's greater, but not with this and this. So we are only having car B combined with the boat one. Now car C will be greater than boat one as well as boat two price, so it will be combined with these two guys, is it? So that's why we have theta join, which has some condition like this, so that we can join them together. But there are many more joins, like we have equijoin. Now what is equijoin? Equijoin means when the theta we were talking just earlier is the equal sign. So we are trying to join the two guys, okay, like R and S we want to join, but there is a equality sign. जैसे हमने ऊपर किया लेस देन इक्वल टू वो नहीं चलेगा, ग्रेटर देन इक्वल टू कोई और कंडीशन नहीं चलेगी, खाली इक्वल कंडीशन अगर आपके पास है, that will be called as a equijoin. So theta should be equal sign, then it is called the equijoin. Now if you look at this table again, the car and boat was joined in the theta join, but if you could see here that we are having the जो आपकी join condition थी, that's car price and boat price, that is coming here. Car price, it is the boat price, okay, they are coming here. But sometimes we say that if this car price and boat price, they were different, okay, but sometimes the join attribute is same, but if you do theta join, it will come two times into the table. So we want that it should come only once because it's the same. Here it makes sense that it should be two times, because it should be here is the car price, the boat price, because they're totally different. But sometimes if they are same, like we are saying equality, when we work on equality, at that time it will be 20,000, it will also be here 20,000. Now keeping two columns is not a good thing. At that time we say we should have only one column, so that's why that thing will be called as the natural join. Now if you look at this example here, that we are saying that we are joining the two tables, employee and department, which have the same here attributes, department name and department name. Now if you could see here is a finance and finance. When we join them together on the basis of the department name, I'm saying that join employee and department, where employee dot department name is equal to department dot department name, कि जहाँ department name same है उनको आप join करें. Okay, and we are joining here, as you could see, Harry with the finance, because finance is here, So here is also finance, so we should put the George with it. And then sales is here, we should put Harriet with this tuple. So we're putting Harriet there. So finance with this tuple we'll put George, and sales we'll put with this tuple here. What, this is from this tuple, and we'll put Harriet. But if you could see, department name here is coming only once. So it is not coming department name 2 times. So this is because we are doing here the natural join, because natural join will allow only one attribute from these two. Got it? So if we would have done something like theta join, it would have said name, EMPID, department name of this, then again another attribute here, department name, then would be manager. Now if you look at the next thing is the semi join. In a semi join, what we do is, where for example join these two tables on the base of common department name. Now we have here sales is coming common and production is coming common. So sales and production, the two things are coming common here. Okay, but in semi join, which is shown by like this, we do not take up this Harriet and Charles from this table. We take only the attributes from R1. So when we say R1 semi join with the R2, we take only tuples from the R1. This is R1, or say this is R and this is S relation. When we are doing semi join these two guys, we take only the tuples from the R which have the common attribute in the S, जो जिसके बिना पे आप join करना चाहते हैं. We need some attribute here which is जिसके ऊपर आप join करना चाहते हैं, which is join compatible. Okay, but we do not take the values from this guy, which was seen. If we do the natural join of this, then with the sales here, sal, there will come the Harriet, and will the Harriet production will come up the Charles, but which is not there. Then there is next thing called anti-join. Now anti-join जो है वो उल्टा है आपका semi join का. In semi join, what we do? What we said if there is a sales and there is a production, is a common attribute. That is these two tuples I have to take actually. Okay, production and sales, and I should be taking only from this table. That was my semi join. But anti join says iska ulta. Okay, so what are the common attribute के बिना पे जो आपको है, उसके बगैर जो बचते हैं, उसके बगैर कौन बचता है? हैरी एंड जॉर्ज, जो कि सेमी जॉइन ने नहीं लिया था, तो आप वो ले लें, हैरी एंड जॉर्ज. Got it? So that's called as the semi join. So these are all the operations we did on the base of the relation based operation, set based operations. But we have a last thing called the division operation. So what's the division operation? We're going to divide the two tables. If you could see here, this is my relation R1. I want to divide it with the, for example, this thing A. This is R2 is this one, B1, B2. This is a confusion on the note, so I will clear it. So R2 is this B1, B2. So in division what we say कि हमें वो attributes लेने हैं इस table में से which have the which are related with the B1 as well as B2. Now if you look here with B1 in this table, we have A1. Okay, we have the A1, and with B2 we have also the A1. So A1 should be taken. That's why we are taking A1 here. But with B1 there is A2, B1 there is A3, but I should have with if I want to take A2, that means it is with B1 के साथ है, but it should be also with the B2, but B2 के साथ A1 नहीं है, so I cannot take the A2. But A3, when I say it is with B1, it is also with the B2 here, so it's also with the B2 here. So I will take my A1 and A3 as the answer. And if like A4 वो B2 के साथ है, A5 B1 के साथ है, so I will not take them. Similarly, if I take my relation is like this one, the second relation. This is first relation R1 and R2 is this one, A1, A2, A3, B5. यानी कि जो हमें वो attribute लेना है यहाँ से B में से अब लेंगे, क्योंकि ये A's हैं, ये B's थे तो हमने A's में लिए, अब ये A's हैं तो B's में लेने हैं. अब हमें बताना कि जो इन A1, A2, A3, A5 सब के साथ है. तो अब अगर आप देखेंगे A1 के साथ B1 है, ओके, A2 के साथ भी B1 है, फाइन. A3 के साथ भी B1 है क्या? यस है यहाँ पे. एंड A5 के साथ भी B1 है. तो इन सब के साथ B1 है, इसलिए B1 हमारा आएगा और बाकी इन सब के साथ नहीं है, सिंपल। इसी तरह से अगर आपकी रिलेशन है ये ए जिसमें कुछ नहीं है तो बी सारा आएगा, अगर बी खाली है तो ए सारा आएगा। तो सिंपल कि अगर डिवीजन करना है किसी से, अगर यहाँ पे बीज हैं तो वो वाला एट्रीब्यूट नहीं आएगा, एज में आएगा, एंड जो इन सब के साथ रिलेट होगा। आई थिंक दिस इज not a quick recap. I guess it is the whole recapitulation of all this concept. Is it or not? So I think this is enough, and it's time to do what? Okay, if I do not deserve the claps, at least I deserve a little bit of smile. Is it or not? So do like that.